Okay, so for number 1, when we deal with rational exponents, the idea is simply just the same with how we usually do it in normal exponents. And by that I mean, in here we simply, since the bases are the same, what we do is we simply add the exponents in the numerator and then subtract the one in the denominator. So by that I mean we will have here b raised to 2 over 5 plus 1 over 3 minus 2 over 15 there. And then from here we just simplify this one here. Take note that 2 over 5 can be written here as, if we multiply 3 over 3, that will be 6 over 15. And then for the 1/3, when we multiply 5 over 5, we'll have here plus 5 over 15. And then copy the minus 2 over 15. And then when we simplify this, we have 6 plus 5 minus 2 will be 9 over 15. And then let's just simplify this one. We'll cancel out the 3, so we'll be left here with 3 and 5. So we'll have here 3 over 5. And then let's just write that one down. Let's move this one first here. So this one will be equal to b raised to 3 over 5. So that's the answer for the first one, pretty standard. For the next one, let's deal with radicals. The reason that this is part of rational exponents is because this radical here with the 3 just means that we have here negative 8 raised to 4 raised to cube. To solve this one, what slick move that we can do here is that take note that 8 here is equal to 2 cubed. So we can actually write this one as the second there. We can write this one as negative 2 cubed raised to 4, right? And then from here, take note that by laws of exponents, we can actually switch this one to here. So we can write this one as the cube root of negative 2 raised to 4 cube. And then just like how we deal with fractions, if you view this one as negative 2 raised to 4 cube raised to 1/3, then obviously the 3's here will cancel out and we'll be left with this. Take note that negative here, we can view negative here as negative 1 raised to cube, since negative 1 raised to cube is equal to negative 1, so it would just remain the same after the radical sign is removed. Let's just mark that one down. So this one will be like this, and then negative 1 here, just to be precise, is equal to negative 1. And so this will just be equal to negative 2 raised to 4, or basically 16. And this is the answer for this item. Okay, then for the third one, here, let's see what we can do. Oh, take note that the inside, which is what we actually call the radicand, we can view it as 9 can be viewed as 3 squared, while x raised to 8 can be viewed as x raised to 4 squared. Okay, and then again, since we can view this as fractions, if we view the fourth root out here as just 1/4, then we know that these two, if we cancel out these two, then this must be 2. Okay, to expound on that one, again, we can view this one as, let's see, 1 raised to 4, and then we have here 3 squared, then x raised to 4 squared. If we cancel these two out, the exponent out here, this one must be 2, right? Since it's like we applied the 1/2 already to be able to cancel out the 2's in the inside. Okay, so I hope you were able to follow that one. So that means we'll be left with here the square root of 3, and let me write x raised to 4 as x squared squared, right? Take note that in radicals, if this one is not present, that just means that this is 2, in case you didn't know. So this means that if we apply the radical out here, 3 will just remain inside because it's not a perfect square, and but this one here will be factored outside since it is a perfect square. So we'll have here x squared square root of 3. Now basically, if you view this alone and this one is 2, so we can cancel that one out, and this will just go outside, like something like that. Okay, good. And then for the call this the fourth item, this one is also quite fun, I would say. You can view radicals as exponents, so this one will actually be equal to 4 a raised to 4 b raised to 4. We have here 1/3, and then on the outside we have 1/2. And again, by laws of exponents, we know that we can switch this one out here. So that means that, let's see, I don't really have space much here. Let's just write it out here. 4 a raised to 4, b raised to 4, 1/2, and then 1 cube outside. And then take note that this one, the 1/2 here, would actually affect these out here, since 4 is equal to 2 squared. So if we cancel out some stuff out here, if we apply rather the 1/2 in the exponent, then this one, okay, so cancel that one, this one will be 2, this one must be squared, this one must be squared. Yeah, not to confuse with the exponent 2. Okay, so that means that we'll be left here with, let me convert back the cube root to this one. We'll be left here with 2a squared and then b squared. Take note that this one is the final answer, since the terms inside here, or what I mean by that is, here in the radicand, there are no factors or numbers, variables with a power of 3 or our perfect cube. So that means that the answer for this one is this one already. Okay, good. And then now for the fifth one. So we have here dividing radicals. When we encounter a radical with a fraction or rational expression inside, this one can actually just be viewed as a radical. A radical 25c raised to 5, and another radical in the denominator. Basically, what we mean by this is that dividing inside a radical is the same as dividing the numerator and denominator, wherein we split the radicals out there. Okay, then from here we just simplify the numerator and denominator. For the numerator, take note that 25 here is equal to 5 squared, so that's a perfect square. And then the c raised to 5 here can be viewed as, then we have c squared squared times c. So basically we'll be left with 5c square root of c. Oops, 5c squared of c. And then for the denominator, take note that 12 here can be viewed as 4 times 3. 4 is a perfect square. I think we've seen that earlier as well. And then a cubed here can be viewed as a squared times a. Then we just left out b since it doesn't have any exponent, so we can't really move it out of the radical. Okay, so basically what we'll be able to move out of the radical is the 4 here, since it's a perfect square, which is equal to 2 squared. The 3 cannot be moved, and then the a squared. So by that, we'll have here 2a, and then we'll be left inside with 3, another a, and b. So I hope you were able to follow that one. Basically, I'm skipping out the radicals, the minor computational stuff and radicals, since this is just essentially a review. And then take note that this is not the final answer yet, since in radicals, we don't really like having radicals in the denominator. So we need to find a way to remove that one. And an easy way to do that is to just multiply this one in the numerator and denominator. So let's do that one. So let's multiply out here 3ab and 3ab. Notice that when we multiply this one, these two out here, that would be equal to 3ab squared. Since in multiplying radicals, we just multiply the radicand as long as they have the same nth root out here. And then we can just cancel out this one and this one. So we'll be left with this. So with that, we'll have here 5c squared. And then again, when multiplying radicals, we just multiply this one inside. Since they are the same, that they are square root. And then, so multiplying the inside, we'll have here 3abc, and in the denominator we'll just be left with this and this one on the inside. So we'll have here 6a squared b, and yeah, that's the final answer for this item. Okay, good. And then let's go 6th item out here. So we have here x squared y over a cube root of something. In here, take note that before we simplify this one, and by that I mean, again, we don't want any radicals in the denominator. Let's try to factor out y raised to 4 out here first. We can do that since take note that y raised to 4 can be viewed as y cubed times y. So to write that one down, in the denominator, we'll be left with a y cube root of x squared y. And then for the numerator, we have here x squared y. And then from here, we can actually cancel here the y's. So that simplifies one part of it. And we'll be left here with x squared times cube root of x squared y. Now in here, unlike a while ago that we just multiplied what's in the radical, or what the radical is in the numerator and denominator, we can't really do that here, because if we do that, then we'll just be left in the denominator with cube root of x squared y squared, and this doesn't really cancel out the radical. So what we do instead is multiply what? Can you think about it? Multiply the cube root of the square of this. So let's look what will happen if we do that one. So we have here x squared y, x squared, oops, it shouldn't be x squared y, it should be x squared y squared and x squared y squared. So what will happen here is that if we multiply these two, then take note that it would be the cube root of, again, laws of exponents, so we just add this one. So we'll have here x squared y 1 plus 2 or 3. And then we can be able to cancel that one out. So to write that one down, so in the denominator, we'll just be left with x squared y. And in the numerator, we'll have here x squared, the cube root of, to simplify, we have your x raised to 4 y squared. Okay, let's just move out here since I'm lacking space. There you go. And then observe here that the x squared here will actually cancel out, which is a good thing. And so we'll just be left with the cube root of x raised to 4 y squared y. So this is actually the simplified form for this problem. Oh wait, actually, we forgot something, and we have space. I guess I'll just do it out here. Take note that in here, the x raised to 4 out here can actually be viewed as x cubed times x. So we can apply the cube root on x cubed. So we'll be left here with, just put an arrow out here. We'll be left here with x cube root of xy squared. So we'll have here x cube root of xy squared. And I think this one is the final answer. Okay, good. Now let's go to the 7th item. So this one is again multiplying radicals, but take note that in here we are multiplying with the different nth roots. We have here cube, or rather square root, and we have here cube. So before you can actually multiply that one, take note that we need a simple adjustment for this one. And take note, the key here is just to view this as 2 raised to 1/2, while this one is viewed as 2 raised to 1. So in exponents with same basis, when we deal with this one, we basically, when we multiply this becomes 2 raised to 1/2 plus 1/3, right? And then to be able to add 1/2 and 1/3, we need to make the denominator same. And by that I mean, take note that 1/2 is equal to 3/6, and 1/3 is equal to 2/6. So if we apply that same idea out here, make this 6 by getting the cube of the by getting the cube of the radicand. And this one, to make this 6, we get the square of this one. So with that I mean, we'll have here the 6th root of 2 cubed times the 6th root of 2 squared. Okay, so let's just fix this one. Basically, if it's kind of confusing, you can view it as the reverse of what we're doing a while ago and canceling this one out, right? So it's basically the reverse of that. It's easy to check that these two are the same as this one. And then from here, since we already have the same nth root, which is 6th root, then we'll be left here with the 6th root of 2 cubed times 2 squared, or basically 2 raised to 5. Oopsies, my bad. There. So this one will be the final answer. You can simplify 2 raised to 5 to 32, I think, but I'm fine with this one. Okay, next we are adding and subtracting radicals. The key in adding and subtracting radicals is to hope that they will have the same radicals left. And by that I mean, if we view this as, let's say, a square root of x minus b square root of x plus c square root of x, Then just like how we deal with variables, this will just be a minus b plus c squared of x. Basically, if we have the same radicals left, we can just treat it like a variable and just combine the coefficients. Okay, so we have some space. So to do that one, for the first one, take note that 36, we can view that one as fourth root of the square root of 6 squared. And then for the second one, we can view that one 54 as 9 times 6. And then for the last one, we can view the last one as 16 times 6. And then take note here that 9 here is a perfect square, 16 here is a perfect square, which means we can factor that out. So we have here minus square root of 9 is 3. And then square root of 16 will be 4 square root of 6. So we'll have here basically 2 here. If we cancel that one out, then this must be 2. So we'll be left with square root of 6. And then here, fortunately, we have same radicals, right? So we have square root of 6, square root of 6, square root of 6. So this will just be equal to 1, since that's technically the coefficient out here, minus 3 plus 4 square root of 6. Simplifying this one inside, and that will be 2 square root of 6. Okay, good. So now let's go to the 9th item. When we deal with this one, again, the key here when we encounter radicals in fractions is that the denominator, we can't really have radicals out here. So what's a good trick to remove this one? Try to observe that we have here a sum. And if we want to get the squares of this sum, so let's say this one is A and this one is B. If we want to get the squares of this sum, what can we do here? Well, recall that we have what we call the difference of two squares, which is basically A plus B times A minus B. So to be able to apply that one here, since we already have a sum here, we just multiply the negative, or rather the subtraction version of this one. So by that I mean, we will have here square root of 6 minus square root of 5, square root of 6 minus square root of 5. So by doing that, we'll be left with okay, let's first focus on the denominator. So we'll have here again, this is difference of two squares. Their outcome is difference of two squares, so that will be just square root of 6 square, or that's basically 6, minus the square root of 5, which is just basically 5. And then for the numerator, take note that this one is the same. So this is just the square of a binomial. So we have the square of the first term, which is 6, minus 2 times the product of these two, which is square root of 30. And then the square of the last one, which is plus 5. And then from here, just to take note, 30 here cannot be simplified actually anymore, since this one is equal to 2 times 15, or when we simplify further, this is 2 times 3 times 5. So it doesn't have any perfect square factors, so we leave it as it is. For the denominator, this will just be equal to 1. Dang, I have quite plenty of space out here, but yeah. So we'll have here, let's see, so this one will become 6 plus 5 is 11, minus 2 square root of 30. 6 minus 5 is just 1, so actually, okay, fine, let's just write it out here. Anything with a denominator of 1 will just be the numerator. And so this one is the final answer for this problem. Oh no. Okay, this is quite... Okay, I think let's just live with that. Okay, good. So that's for the 9th item. For the 10th one, here we have, again, our goal is to eliminate the denominator. But in here we have cube roots. So if a while ago we used difference of 2 squares, this time we can use the difference of 2 cubes. If we view this one as a minus b, recall that when we multiply your a squared plus ab plus b squared, then this one will actually be equal to a cube minus b cube. That means that the cube root of 4 will just become 4 and the cube root of 3 will just become 3. And the key here is what we multiply. So let's multiply out here. So we need the square of this one. So that would be cube root of 16. And then we need to get the product of this one. We'll have plus cube root of 4 times 3 is 12. And then lastly, we take the square of this one, which is plus cube root of 9. Okay, then let's just copy the denominator. Let's fix this one. There. Okay, let's just put it out here. So this means that the denominator again will just become the cube of this one, which is just 4, and the cube of this one, which is just 3. And for the numerator, this is just 1. Let's just copy this one. Okay, let's see how to change the color of this one. There. Okay, good. And then from here, take note that the denominator will just be 1, so we can disregard that one and focus on the numerator instead. Here, take note that 16 is equal to 2 raised to 4, or 2 cubed times 2, so we can actually factor out the 2 cube out here. And so we'll be left here with 2 cube root of 2. And then for the other radicals, we can't really simplify this one, since 12 is equal to 2 squared times 3. No perfect cubes. This one is 3 squared, so yeah. So we'll be left here with cube root of 12 plus cube root of 9. And so this one here is the final answer for this problem. And then last item, so we have here 1 over square root of 2 plus 1 over cube root of 2. Again, the goal here is to remove this one and to be able to combine these. You might be thinking, oh, I'll just use the butterfly method. So multiply this one, add them in the numerators, and then multiply this one in the denominator. But take note that we have seen earlier that when we multiply this one, there will still be a radical in it. So again, you have to be smart whenever you use the butterfly method. And so in here, what we can do instead is, let's just move this a little. What we can do is just to make the denominators both 2's. We can multiply here square root of 2 over square root of 2. Let's move this out a little more. And then for the second one, we can multiply out here cube root of 2 squared, or simply just cube root of 4 all over cube root of 4. So by doing that, we'll be left with, for the first one, we'll have square root of 2 all over square root of 2 times square root of 2 is just 2 plus cube root of 4, and then the denominator will just be cube root of 8, or simply just 2. And then from here, let's just combine it. And so we'll have here over 2, we'll have square root of 2 plus cube root of 4. And yeah, that's basically the answer for this problem. So those are our exercises for rational exponents and radicals. So it's quite a lot, but it's a good practice for you to know the different tricks involving radicals. This will be especially important when you encounter, like example in calculus, limits that involves radicals. You need to plug in something, you need to maneuver things. Yeah. So that's basically it for this video. I hope you enjoyed that one, and we'll be having the last part on the next video. If you have any suggestions, just put that down in the comment section down below. And besides that, have a great day.